Here, if you see, the electrical discipline plays an extremely important role. As you know, in the building sector also, we have to deal with electrical discipline. Here also, without electrical, our HVAC systems cannot run. So this is the reason HVAC and electrical are like husband-wife. We need to always work together towards a successful completion of project. For that, what we need to do and what inputs are needed from us to them and them to us. Simple thing. There is voltage and frequency. Voltage is essential because 400 volt or 690 volt, because 400 volt is LV, low voltage, and it goes to 690 volt, it becomes MV. So selection of motors is different. So we need to always ask them that what is the voltage entire platform you are considering for. It is LV or MV, because based on that your entire HVAC system is going to change the electrical aspect. Cabling will change, your transformer will need to add or motor will need to select differently. And the frequency, so 50 Hz or 60 Hz. Majority of the oil and gas platforms are 99% of the 50 Hz, but still every time you need to ask, because surprises are very common in this sector. Why 50 Hz, 60 Hz is important? Because 60 Hz, as you know, the RPM of motor is higher, and 50 Hz is RPM of motor is lower. So of course, if you are selecting a wrong hertz or wrong frequency motor, your output for the motor, maybe it's air or refrigerant, is going to be different, and it may be over capacity or under capacity. So selection plays very important role over here. So these are the two things you need to keep in mind. Voltage and frequency, you need to ask them, because based on that your equipments are getting selected. Second is heat dissipation. Heat dissipation is of course not in your hand. You have to get the inputs from the electrical, because electrical is the one from which the motors are there or the electrical panels are there, from which the heat is going to be dissipated from that. Apart from the human heat or the electrical lighting also, they need to give what kind of lighting they are using. It's LED, incandescent light or whatever, they need to tell you. So based on that, heat dissipation value is also there will be, as long as the motors are considered, as long as the electrical panels are considered. Of course, there are certain thumb rules which I'll tell you later if they don't give, but you should push for always these values, because if they don't give, you will be in trouble. So you have to always ask for it. Next, what thing we need to ask is the HVAC electrical load. We need to give it to them. Remember, they need to design the electrical panels, they need to design the electrical distribution board. So to design that, they need the electrical load. So tentative calculation for electrical load, because you know this airflow, you know the static, you are a mechanical engineer, you can calculate the shaft power easily. And once you calculate the shaft power, don't worry, I'll give you the formula for that also. Then definitely you can add some contingency and you can divide it by the motor efficiency. So you will get approximate size of a motor, how much kilowatt it is. So losses considering how much motor load, I will teach you how to do that also. Very simple thing, very simple formula. So once you do that, whatever the motor load tentative you arrive, you need to give it to them. Or you don't want to do it, simply approach, if you have contacts, to any of the AHU vendor, give them a data, he will tell you the motor size what is needed. That is a very simplified and authentic source. But you know, at the initial phase of the project, no vendor will entertain you unless you are a big client. So few things you need to do the calculations, and always bit oversized things you need to give it to electrical, so that afterwards you can easily optimize and give it to him. So this is the electrical load part. Next thing you need to consider is electrical panel specifications. Most of the time what happens is electrical discipline is too busy. So at that time you need to take charge. It happens that project to project, some to project are NOSOC project, for that form 4, form 2, form 3. See, there are various types of this electrical panels are there. Form 1, form 2, form 3, form 4. Form 4 is considered as a very stringent, and for the 𝗏𝗏𝐶 applications, form 4 is being preferred. So being said that, here electrical panel also plays very important role. The specification is very important. You need to take care of that also. Then duty standby configuration. One motor is duty, another motor is standby. So those inputs also you need to give it to the electrical discipline. Then comes the requirement of isolators. It has to start together with electrical and tell that maintenance purpose you need isolators in each of the major equipment, so that if some fault is happening they will isolate and do the maintenance, so that there should not be any hazard or accident, and safety point of view also it's good. Then the damper voltage, it is whether damper is electrical, pneumatic, whether it's 230 volt or 24 volt AC or DC, various types. Dampers comes in various types and configurations. So you need to give this data to the electrical discipline. Then you need to design the shutdown philosophy, because suppose something happens on the platform, suppose the gas is detected, fire is detected, then how your control panel or HVAC panel will get closed. That kind of a philosophy you need to sit together with technical safety discipline, electrical discipline, instrument discipline, all major discipline. They have to sit and need to design the entire system shutdown philosophy. Then normal and emergency distribution load also we need to do, because when any emergency happens, your all your staff is all your crew on the platform is going to take a refuge at particular place, that we call it as a temporary refuge, and you need to keep certain equipment running in that case to maintain the cooling for that particular requirement and pressurization for particular zone. In that particular requirement, you don't want your laundry fan to run, you don't want your kitchen fan to run, you don't want your toilet fan to run. You can tolerate those 4 hours without that. So you are reducing the load and you are putting it on the diesel generator, which will run and which will provide the air conditioning which is just enough for the 4 hours for those people who are gathered at that particular location. So that particular requirement also you need to inform the electrical, okay, this is the requirement, this is the people are going to stay here, and other things I don't want you to take off the load. So he will account for that particular load only when he's designing his emergency diesel generator. So this also input we need to give it to electrical. So there's a lot of give and take between electrical and us. So we need to keep in mind always. Let's go to the next slide.